In this video, we're going to talk about the static keyword. So everything we've used up to now is non-static. And you can see I have this private int age. So this is a declaration for an instance variable. This would be considered non-static. These are like the instance variables we've been using up till now. So these belong to the object. Remember when we have a class and we create an object, you can think of the class as like a template. We take a copy of that class and we create an object with it. And then when we create a second object, we take another copy of the class and create another object, create that second object. So both of those objects have their own instance variables and their own methods. These are non-static methods and variables, and they're what you've been using up till now. But we have a keyword called static, and you can see here this declaration for this variable. I've used the keyword static. What that means is it belongs to the class, not the object. So when we have our class template and we copy it to create an object, the static variables do not get copied to the object. They remain with the class. Static methods are the same. Static methods do not get copied to the object. They remain with the class. So if we create two objects from the same class, so they're the same type of objects, and there is a static variable or a static method, that does not get copied to those objects. That means that those objects will share that variable. If one writes to it, then the second one writes to it. It will overwrite the data that the first one has written. So let's have a little bit of a look at an example of this. It'll make it a lot easier for you to understand. So you can see I have this student class, and let me just bring up BlueJ here. I have this student class, and we can see it has a name and an age. We have a constructor that sets the age. We also have a mutator method that sets the age and a mutator method that sets the name. So if I create a new student and I make this student 20, and then I create another new student and I make this student 30. Now let's have a look at the state of these objects. So if I inspect the first one, I can see the age is 20. And if I inspect the second one, I can see the age is 30. Neither of these variables are static. This is what we've seen up till now. When we create an object, so this student object has its own copy of these variables. This student object, student 2, also has its own copy of these variables. The same goes for the methods. If I right click on student 1, I can see it has a set age and a set name method. If I right click on student 2, I can see a set age and a set name method. Both of these students have their own copy of these methods. So when I write to the age for this student, it gets stored in its own copy of the age variable. When I write to the age for this student, it gets stored in its own copy of the age variable. So far, this is what we have done. We've done that up till now. But if I was to declare this int as static, using the static keyword, and I compile it, now if I create a new student and I set the age of this student to be 40, look what happens when I inspect it. There is no age variable. The age variable belongs to the class. So when I inspect the class, I can see the age is 40. Now if I create another student and I make the age of this student 25, notice once again it has no age variable. The age variable is static, so it belongs to the class. When I inspect the class, the age is now 25. Now I'm going back to the first student. I'm going to set the age to 70. Now look what happens when I inspect the class. The age is 70. I'm going to go to this second student, student 2, and set the age, and I'll set it to 10. Now when I inspect the age variable, we can see that it's 10. So if this student writes a value for age, it will set the age variable in the student class. But then if student 2 also sets the value for age, it will overwrite the age variable. There is only one copy of the age variable. Both of these students will have their own name variable. So if I set the name for this one to A, and I set the name for this one to B, now if I inspect student 1, I can see the name is A. If I inspect student 2, I can see the name is B. They both have their own copy of the name variable, but the static variable is shared between them and it belongs to the class, not the object. The same is true for methods. If I declare this set name, actually this set age one, so public static set age, and I compile this. Oh, I can't do this here. I'd have to just say age because we're not referring to the current object. So age equals age. Now look, if I right click on student, there's a set age method. And when I create a new student, notice it no longer has a set age method. The set age method belongs to the class. There is only one copy of the set age method now. Because it's static, it belongs to the class. So if something, an instance variable or a method is declared with the keyword static, it belongs to the class. If it's non-static, it belongs to the object.